Start recording. Okay, so we're gonna probably have a fairly easy lesson today. I think is the order of the day. So the last thing we were doing is exactly what you have up on screen. I will run it too because video compression is making these thin lines hard to see. So we have some axes. We have 6 of them, to be precise, and we've bundled them all into an array. Have we bundled them all into an array? I think we got that far. And what we wanted to do was make a diagram like this one for the circles. So basically, we're just going to be, we've kind of done all the work, and we're just going to conglomerate it all into a single bit of functionality over here. So let's start with the projection. So over here we've got this section. I think we if falsed it out, and what it was doing was drawing us this axis and then projecting us onto this axis. So what we want to do is we now want to project onto the axes that we've created here. So I'm pretty much going to hand it over to you. I think we don't really necessarily need to draw the arrows. We do want to draw this like final result though. So we have 2 shapes and then we have a loop full of axes. So let's see what we can do with this.
Okay. Blah. All right. So these are the projection lines.
Yeah, I mean we could chuck them in if you wanted to.
Well, that's the rectangle and that's the circle, but we're kind of like.
Is that?
Yeah, we have.
I
think like
no,
these
the
are TL.
circle's up here. So.
Oh, what's this arrow then? This is the max.
So that's.
Well, we have the 6 points, right? We have the 4 points on the. We have the 4.
Hang on. Well, why don't we run we'll run the code and we'll have a look at what it does. So.
Yeah, that'd be helpful.
So we have an arbitrary number of rectangles.
That's right.
And
but here you're only I can only see the 4 the 4 points that you're kind of projecting from there.
So that's.
And then the other the other arrows. Oh yeah, these no.
That's the red one. Is the second one you're pointing at, unless we're pointing at different code.
Well, okay, we'll look at my code.
Yeah.
This is the obviously red, so this is the red arrow for an arbitrary number of rectangles. So yeah, that's the red arrow. Okay. And these are the projections of the rectangle. Okay. So so now my computer's just going nuts here for some reason. Didn't like that. Throw me somewhere else.
They tend to do that, don't they?
All right, so this is circle versus square rectangle. Here's our bag of axes. We still haven't. We kind of went off last time. We still haven't kind of like moved these anywhere, but I guess it really doesn't matter right now.
So yeah, well, later on we'll come up with something better than an array being allocated at the time
every
of drawing.
Tick.
Every frame. That's obviously no good. So. It might be the sort of things like to do.
It's simple. Yeah, as simple as allocating a fixed size array as a field constructor, and then this isn't a big deal.
So what that might turn into could be as simple as doing a stack alloc. We could look at fancier things, but this is the sort of thing where we start to run to the limit of what C# can do for us as far as performance goes.
So if I'm going to make a projection, I have to project it onto something, and in this case, the axis isn't necessarily the right thing, because we have an axis and then we also have, in this case, I guess the position is what we want to project it to. And then, so we're just trying to think here. We're drawing, kind of like this arrow here, where this is the projection and this is the position. I kind of want to just run that because I'm not exactly sure.
Well, that's a reasonable thing to do.
Okay, so what have I wrought? So now the pink arrow, yeah, I mean, I can't even make sense of that. But just so I'm clear, like, we want to project this here, right? This here. But aren't we already kind of doing that? Like,
So for some of these,
where's the axis line that we're trying to?
well, there's six
I
of them.
I kind of just forget what we're doing.
Okay, so that's why we have six. So there's in this loop here, there's 6 axes that are occurring.
That's right.
And so what we've got, if we come down here, the first, I mean, there's problems with this code, but the first problem is you're projecting position to the axis. Then you're drawing an arrow from the position to axis times projection. Now, this axis is just a direction. It has no, like, this is the thing where you need to conceptualize whether when we have a vector, whether we're talking about a absolute position in world space or like a relative position or just a direction. And so what we've got is we've got a direction times a length, but this is not really going anywhere. So what we probably want to do is if you, so this is the code. This is the code where that came from, and this is another case of, to get this axis into world space, we have to think about where did this axis come from. This axis came from mouse world position, and we've we've cheated a little bit. We've elided. It's like, okay, we want the mouse world position relative to the origin. So there's like a vector 2.0 here, and then if we want to like draw something onto this axis, then there's like a vector 2 plus axis there that we've sort of skipped over because it's a 0. So what's happening here is when we get an axis, it's top left minus circle position, bottom left minus circle position, and then over here we've actually gone and got a position for what that's relative to. So if we want to draw something onto the axis, we're going to want to take this position and draw relative to it. So over here where you've got axis times projection, no, over here, so you've got that there. That's how you get
the axis and the position.
Yeah, so over here where you're drawing an arrow coming off the position in the direction of the axis, you're adding it to the position to get that arrow pointing in the right space. Like you're getting an arrow that's on that axis. And the same again here, you've got position plus axis times a thing. Over here, you've just got axis times a thing, which is why this is not working.
So I'm scaling, but I haven't added the, this is the direction. This is the, I guess I don't know what this is anymore.
Well, that's the projection of the position onto the axis, but what you'll probably find is that's, actually, I don't think that's going to be 0, is it? Maybe it is. We should find out. So let's finish off this code you're doing. Let's fix that one bug. And I'll just catch up to where you are.
It's not 0.
Okay, so I've written out the same code as you, except I've added this position plus over here. So let's see what this does. Let's turn that code off. And so we have that, and we have that. Okay. So yeah, so this is obviously not necessarily what we want. So something has gone slightly wrong here.
But I don't actually know honestly, I don't know what the final result would even look like. I kind of missed maybe the plot in the beginning and what we're actually trying to draw. Just like make it look like the other thing, but it kind of already does to me. So.
All right, let's rewind a bit. Let's comment that out.
Which axes are we trying to draw an axis between these two shapes and then project our 6 directions onto it?
Let me draw something out. So I'm going to take a screenshot of that and shove it over into the paint thing. And get this thing. Okay, so let's say we have an axis. I'm going to pick this one here. So this one here. And we're going to have to do this for all 6 axes. What we want to do is we have 2 shapes now. We want to project that shape onto this axis. So for the circle, which I'll do in, say, green, that, we're going to project this point onto this axis, and we're going to get 0, obviously. We're going to then have to do that thing where we're like, all right, we'll take the radius and we'll project there to there on this axis. And so that's going to end up, we're going to want to draw like a line across there to indicate that we've done that projection. Then we want to take our rectangle and we're going to want to do the projection again. And the rectangle, as you recall from the previous code we had, has these 4 points. So taking the projection from the rectangle will go from there to there. This will stay about there. This will go down to here. And this one will go down to there. And so we're going to end up...
that makes sense. What you mean, you just picked that axis for... It's arbitrary. But I guess the other one was arbitrary too, because we based it on the mouse position.
Yes. Well, the thing is we want to do this for all 6 axes. So then we'll do like this axis here. So this one runs there. And so we're going to get a red line here that runs there. And then our green line for this axis is going to go from... where the edge of the circle is, from there along to edge of the circle to there. So we're going to end up with this is why I was saying these lines here, the ones that like run from there to there, we may not want to draw because this diagram will get very messy very quickly. But for the actual projection onto the axis, it will be okay. So
yeah.
That's the general plan. That's what we're aiming at.
Okay. Let me start this over then, because so when we have an axis, this is the axis we want to project all of the points on.
Yes.
Right, and the points are actually this, and then this. Well, where are the other 2 points?
So those are the axes.
These are the points, and the positions are the points.
No. Let's scroll up a bit because we actually have this code.
No.
So if you scroll up to this section here, you can see when we do a circle, we have a single point that we're projecting, and that is the projection comes from the circle position onto the axis. And then we just go minus the radius plus the radius. For a rectangle...
Let's, you know what? Forget the rectangle right now.
Fair enough.
I'm going after the circle.
That's probably a smart plan. Let's do the circles first.
One thing at a time. And I almost feel like, okay, I guess I get thrown off by the fact that we've kind of already like grouped these together. But in reality, I do have to like go through every circle, right?
No, we have a single. We have a single circle that's relevant for these axes. So yeah, but otherwise, yeah, this is actually a pretty good plan. So let's skip that loop, but copy in the rest of the code. Hey.
Yeah. So this is the code. I just want to read it for a second here. So we're projecting the position to this. Yeah, so these are the 6 arbitrary axes. Taking one of them, getting the dot product, which is to give us, based on this position. I want to get the direction I'm projecting towards. So I don't have to do anything here, I don't think.
I mean, the code seems to be error free, so I mean, we could just run it and see what it does.
Yeah. So much for nice and simple, even though it is half of it's just knowing what you're doing. Okay, so yeah. Okay, so not quite.
It's looking pretty close. We have
Well, I disagree. These are all perpendicular. These don't make any sense.
so we're projecting up onto here. So the problem is that we're not accounting for the visualization of the axis itself. So I mean, let's simplify this a little bit. Let's go back into here and be like, all right, if I is not equal to, let's look at axis 2. So if I is not equal to 1, continue. And then we can just focus on a single axis. And now when we do that, we can see that we're actually doing something that's pretty reasonable. We have our axis that's going in this direction, and as we know, like just sort of mathematically speaking, it's a one-dimensional axis, so it doesn't really matter how far off it perpendicular we are, but obviously it messes up our diagram. So that's what we need to fix, basically.
Well, I mean, I'm kind of confused to where we got the pink arrow. I mean, I know it's part of the code, but like but the pink arrow is kind of like messing with me, because like we want, like this red arrow, we want it down here.
So basically the pink arrow, we want that to equal 0. So we've got a little bit of algebra to do. In other words, to remove that distance.
But where is the distance coming from? We don't have a distance here, do we?
Let's have a look.
We have a position. We're scaling the direction by this projection. So this projection is the distance, really, because we're scaling by that. So, I mean, so why do we even have the dot product here?
Well, if you recall, as I was saying, we're doing this like this. Okay, so this is what I was saying before, and hopefully my maths is right here. But before, when we had an arbitrary axis, we were going world mouse position relative to vector 2.0, and then when we went to draw along this axis, we were eliding a vector 2.0 plus this, because the axis is just sort of it's non-spatial. So
but we're doing that here. We've elided it here. Like it's not.
Yes. So this is the point. If we then go and look at where our axis is coming from, this is not. This is not vector 2.0. This is in fact circle.position.
Yeah.
Which is
I mean, I figured that we yeah. I mean, okay. I mean, you told me the answer, but the weird thing is that like we normalized it already, so that didn't help.
Yes. Now, whether or not I'm right about that, and I don't think I am, I'm trying to think about. So I have a maths problem here, and you can sort of see where it is. We're now on that axis, but we're now shoved slightly over to the side. So, like, rather than going up, we're going back that way. I'm trying to think about why that is. So I'm just going to bring back my marker for the origin. So you can see if we draw it around the origin, we're correct. So we've got the offset slightly wrong, is the only problem. I'm trying to think about why that is. I think I know what it is. I think it should be this. Oh boy. It could be one of those days.
That's okay.
Where
it's definitely one of those days over here. Like, I figure we already got rid of the extra, like when we normalized it, we got rid of the extra distance, so I think the direction's pointing upward, and maybe the dot product itself is wrong. Like, maybe the circle position should happen here.
No, the dot product is correct. That's 100% correct, and we know that's correct because when we like this diagram, like this diagram is correct in so much as it's calculating the projection correctly. And if we go in and we can like check all of these, we can be like, all right, what's 5 like? And we go in here and it's like, you know, this axis is projecting correctly onto this axis. It's just drawing it in the wrong spot.
Yeah.
It should be drawing it down here.
Well, yeah, I mean,
and I'm trying to think about why that is, and I think I know.
Okay.
I'm just trying to make sure I know for sure. So this is the position this axis is starting from, and it's projecting in this direction. So all of the points we draw need to be along this line. I think axis times, yeah, and in fact you can see exactly what's going on. If you pretend that this, you can see if you pretend this axis is starting at the origin, like imagine that invisible line. It's all coming relative to the origin, and what we want is we want it relative to this position here. So that's the maths that we're trying to figure out. So does that make sense so far?
Yeah. Except that we just did that to the pink arrow and not to the red arrow.
Well, I'm not going to worry about the pink arrow quite yet, but you can actually tell if I draw it slightly off the thing, you can see the pink arrow starts here and comes down.
Yeah, well, it's actually, the pink arrow is always drawn to the spot that we don't want the red arrow to be. Like, you know, like the pink arrow seems to be the thing that the red arrow is sitting on, like no matter what you do.
Yes.
So they're obviously related.
Yeah, so what we need to do is we need to work out how long that pink arrow is and subtract that from everything we have. So we've actually got all of the points here that we actually need. So, I mean, let's look at what the pink arrow is. The pink arrow, we call it the pink arrow for now, is axis times projection minus circle dot position, because it's the relative position between this one and that one.
That makes sense.
So I mean, what happens then? Yeah, and then if we subtract pink arrow from everything, yes, that's actually correct. Except this one, because that is actually we do want to show where our.
Yeah, I don't remember what the value is of the pink arrow.
So.
You don't even have the pink arrow anymore.
No, well, because it's 0. Because I've explicitly.
Oh, you removed it.
Made it 0.
I don't remember what the value point of it was.
However, this is also wrong.
Yeah,
because
the arrow should be on the axis.
It should be on the axis. So
now it's normalized to the position of the circle.
Yes. So it was a good attempt.
There was an attempt. I
An
think that's
attempt
what
was
it
made. Yeah, it really is going to be one of those days. Okay, that's fine. Um, that's unsurprising, actually. The projection of the position onto the axis minus the key. Okay, let's back out all that change. Okay, so we're back to this point. Yeah, and you're quite right. Okay, so yeah, I'm like, oh, let's get rid of the pink arrow, and it's like, no, the pink arrow starts here. So obviously we've just moved that whole thing onto the center of the circle, which is not where we wanted it. I think the reason is that would have been right, sort of, if we were in this case, and it's like, well, that's not the case we're dealing with. Like in this case, we do actually want to get
Right.
rid of all of that, but that's not the generalized case for axes in general. So let's have a little think about what we are doing here. We have a projection onto this axis relative to the origin. I think what we want to do yeah, okay. So I think I have this figured out. So
Oh, the pink arrow is supposed to be from the circle position to the axis that we're projecting on.
yes,
That's what
so
that
we're
is.
actually the section we're trying to get rid of is this top section, not this bottom section. So
Yeah.
it was a good thought, but it was wrong. Um, here we go. Okay. So there was a step missed in the preparation. That's fine. So what we want is we have this axis here that starts at a position and goes out that way. And then if we have a negative value on there, it goes the other way. And we want all of our points to appear on this line. Now, what we have here is we have this line here. And we know that this is the origin. That's if we project something onto there, it's going to be relative to the origin, which is of course 0. So if we project, if we draw the line 0 onto this one, we know it's going to appear here. What we want to be the case is that this is our different coordinate system here. This is going to be our 0 for here because we're adding everything onto this position. So it lines up with this arrow. Does that make sense so far?
Yes.
So we have two separate coordinate systems. What we're trying to do is convert from this one here to
the origin based one to
this one here.
Position one, the position that we currently have in a variable in the loop. In this case, it's rectangle position.
Now, what would
That's
happen?
just-
Well,
yeah.
what would happen is if we simply added this position, because we know this is a position in space. It's a vector. It's that there. If we add that on, what we're doing is we're doing this, and this is why we end up with, this pink arrow ends up way out there, and then if we did that to the red arrow, it would end up there, which is, obviously not what we want.
Right.
What we do want is to move everything basically down onto this axis. So we want to go down here, we want to go down here. That's going to get our red arrow correct. It's going to make this pink arrow correct because we'll take it from there down to there.
That's right. Yeah.
And so how do we do that? Well, we want to take the origin down. We want to take it down to here. So we just have to work out this
So we
thing.
have to dot product the origin down to the position.
Something like that sounds about right, because you can see that this is a 90-degree angle. So there is a projection going on here. So all we have to do is work out what that projection is. And I think what we'll find that it is
Right. 'Cause the axis is in normal space, and because we literally are normalizing it, but the position is not. So we have to. I see. That's what I thought. It's like float projection is. It's a dot product of the position to the axis. Like, isn't Isn't that exactly what we're trying to do in that
That is
projection variable?
that is absolutely correct. So you can see if I negate this position and project it onto the axis, it's going to give us this distance here. So let's try that. It's basically neg position dot axis. That should be correct. Shall we give it a go?
I said that the dot product was wrong.
Which one did you say was wrong?
This one.
Well, this is the thing. That one's actually correct. It's not that one was wrong. It was we were missing some other ones.
Okay, so I know I'm lost again because
that's all right.
I thought, I mean, this is the prediction that, like, this here is basically, Wait a minute. Oh, we're missing. We're totally missing. This isn't even what we want to draw, is it? Because we're talking. This is all based on the circle. No, yeah. So we pick an axis, and we're trying to draw the circle. The circle's projection, which is the red arrow and the line. But you're working on the rectangle, which is not what we're working on right now.
When we do a dot product, we actually have no way to project onto this axis specifically. We actually have to project onto the axis as it appears at the origin.
Sorry, say that. The axis as it appears at the origin.
So
you mean the logical position of where the origin is? But that doesn't make sense because there is no origin. The origin is it's not really there, right?
I mean, it sort of is.
I mean, in this diagram, that little arrow box at the top left, so like the little axis compassy thing at the top left, is the axis, is the variable axis here.
No, this is the origin. Like, this is coordinates 0, 0 in world space.
Okay.
And so what we have here is we have a circle.
Right, this is gray arrows lines the axis.
That is in world space as well. And if we project it onto the axis, we're going to end up here. So far, so good. And then if we want to draw it, which we're doing here, we're projecting onto that, we're doing that all correctly. That's all correct. But all we want to do is we want to take this drawing and we want to draw it on this axis here. And so to do that, this green diagram here, if I draw this in the opposite direction, if we project that onto here, this is the projected version of this. I'm going to call this one something else. I'm going to call it Q.
Yeah, but sorry, I'm lost because we're not talking about rectangles right now. So why do I mean, I guess the rectangle's there, so I have to consider it. But you're saying we're missing the.
There's two. We're not projecting. Whoa, what happened there? We're not projecting the. We're not projecting the rectangle. If we were projecting the rectangle, we'd be like doing the points of the rectangle. This is an axis that we have that's derived from the rectangle. So we don't have a rectangle so much as we have an axis pointing in that direction.
Yeah, okay. The rectangle's just there because it happens to be like we're in index. In your case, we're in index 5, right? Which is
correct.
0, 1, 2, like, which is the last one, which is the rectangle position, which is the one that axis is based on.
Yes.
Okay.
So this is just an easy axis to work with because it's a straight line. We can draw that nice and easily. But this maths will work out for every other one.
Okay, so you want to get the
what I'm saying
of the rectangle position to the origin, and then basically offset the red line by adding that result to it.
We want to draw this.
Yeah. I think I barely got what you're saying. So I think it's like.
So if you look. look at the distance between there and there. That's the distance we want to calculate. Once we have that distance, we just add it here. And then we have, everything lined up on this axis. So this distance...
Well, how's that gonna... That might be true for the distance that way, but it's not gonna move it down. Like
well, moving it down is easy, because this is why we have to remember that we're working in one-dimensional space. So we've got a 1D axis here and a 1D axis there. So all we're doing is we're drawing this one on this axis, which is, and this is where you'll recall we had, vec2.0 plus, axis times question mark. And so using this formula, we can create any point along this axis. Does that make sense that that's how that works? Sorry?
Makes sense. Yes.
Yes.
Yep.
Yes.
I get that.
So all we have to do is say that, okay, if we want a point on this other axis here, this is Q plus axis times question mark only like dash or something, like some different point will give us points along this line. So all we have to do is make the translation from, this form, this one here, to this one here. So we just have to do that to line it up.
Yeah. I don't know. I don't know why. This is the circle position. This is the position that happens to relate to the rectangle. This is what I think is the origin. Wait, actually we have the origin somewhere up here. Where is that guy? Origin was basically the mouse world position. No. We'll call this the origin axis, maybe. What if this is this? I don't know. Sorry, I don't know.
No, that's fine. I've because I missed a beat there. We've gone around in a bit of a circle. So basically, let's go step by step and try and reproduce. It's looking a little messy now. Let's try and reproduce this diagram. So I'm gonna do that. So first of all, let's say we have. I'm going to draw this axis over here. So we have all of this already, and we have. I'm going to call this A. We won't worry about the red line for now. But the red
but we don't. We think we don't have that. We have an axis. Yeah. Okay. So the axis that we have in the code that we've accessed through the array is the black line. It's just we haven't moved it to where it is relative to the position of the position that's paired with it. Right?
So we have A. This is a circle position. And we have, I'm going to call this B, and this is the position associated with the axis. So this is B.
I'm going to rename everything now. I need to rename it over here too, because it doesn't make sense anymore to me. There's A. And this is B.
So are we happy? I unfortunately want to have this diagram up. Let's try and do the both at the same time.
So when it comes to the red arrow, so how did we get there? So the red, I mean, yeah, I don't get it.
Let's not worry about the red for now. Let's just worry about this pink one. So maybe like make that much bigger so we can see it over the top of everything or something. Sorry, not your text size. I mean the arrow itself, like the width of the arrow. Okay, so projection a.axis. So that's fine. Cool. Okay. So one thing that might make this easier is if we're working off axis 5 rather than axis 1. Okay. So we're happy with A and B and A project. So we have those 3 points. So okay.
To change the color of this. Sorry.
No, that's all right. Okay, A is that. A is circle. B is that. Okay. Right. That's straight lines. All right. Let's try and make this work. So what we want to do is we have one projection. We want to do a second projection. What we have here is B project. Does that make sense?
Yeah. Yep.
And in fact,
because then you'll get. I mean, I thought you wanted that to get the distance, the vertical distance. I don't know why you need it for the horizontal distance when we actually already know that we're in the right spot for that. But
well, that's all right. Why don't we just slap in a drawing code for B project as well?
Okay.
So while we're doing that, because then we can see where everything is.
B axis. Okay. That's another good contrast color. Okay.
Okay.
That's a little odd. I mean, I guess it's not.
So this is where the sort of the step of, I don't say logical leap, but like this is the step in the logic that's sort of the important one to keep in mind. So what we have here is a 1D axis. It's what would you call it? A ray? It's got a position and a position, and then it's got a direction. And this is this one here. We have the same thing down here. This is like B going in the direction of axis. And we're trying to transform between these two 1D axes. So if we look at this diagram, it's like, all right, we have A project here. Now I'm having the same color problem. Nice dark purple. So we want this point here. Let's call this A prime. Now, the thing about A prime is it is the same distance along this axis, this distance here. It's not a very good way of drawing that. A prime is the same distance there as B project is to A project. So that's the important thing to see. So do you follow how that works?
I wouldn't have reasoned that I needed it. I would just be like, oh, I now have the purple arrow, so I'm just gonna take the, this is wrong, but now I'm just gonna take the purple arrow and subtract it off of the red arrow's position, like the red arrows, I would, put in the end position. I would just get rid of it so that the arrow would go down to the line.
I think what you'll find is that mathematically speaking, that is the same thing. So the way you're approaching it, which is certainly not wrong, is basically I have a vector here. If I have this green point here and I subtract that vector, I'll get down to A
That's
prime.
right.
Yeah.
That's right. That's what I would. Yeah. So I wouldn't have thought about this. I wouldn't have thought at all about A prime to B and then B proj to A proj as a result of that.
So that's why this. So you're right. So in 2D space, that's probably what you'd do. But
I'm in 1D space.
But in 1D space, we have to do something. Well, we don't. Yeah, we kind of have to do something a little bit different, and this is probably the way to approach it because it is a axis projection problem. We are in 1D space.
Yeah, I still don't. I mean, I guess to me, it's just like I just don't know. Like, I'm not looking at this going, oh yeah, I need A prime, because A prime's this silly spot halfway in the circle, happens to coincide with the axis along the line there. But
well, this is the diagram we're going to eventually get to, which is like there. We're moving that whole red arrow down to here.
That's right.
And the reason for that is literally because it is on this axis.
That's right. So I guess I mean, sure.
So
I get why. I mean, yeah. If you want to move the green dot, you want to move it to where the purple dot is, because that's what like you said we're doing. We're projecting one D axis onto the other one, and that's where that one belongs on that axis.
Mm-hmm.
But yeah, I don't know. It's just going to be things. It's a practice or awareness thing. But yeah, okay, I'm with you.
Okay, so let's basically what we're trying to do is we're trying to get this distance, and we're going to call it Q. And we have this distance which we now know is also called Q. So let's try and calculate Q, and then once we have Q, the rest of it, falls into place really quite easily.
Okay, so so it's distance between. I mean, we don't have a prime, but we do have a project. So Q is wait a minute. Wasn't it just A project?
Mm-hmm.
As B project?
Yep.
It'll give us the top Q, which is the same as is the same thing as the bottom Q.
Yes.
But that's not. I had nothing to do with A prime though. I didn't have to find A prime to get that. I just know that I use what we have here. Is that wrong?
No,
or
that's
do
correct.
I need to go?
This is why this code is here, is because this is what we have so far, and we're just adding onto it. So we have Q now.
Right,
and we're pretty much done at this point. We just need A prime, I guess. So let's write down what A prime is, I guess. That's
Oh, it's B plus Q.
so.
Wait a minute.
So now you've hit that issue, which
Oh,
is
yes.
we're going back from our 1D space into our 2D space.
Right.
So this is pretty simple to do, fortunately for us, because we know how to do this. So this is what you're about to write is going from 2D to 1D.
Right. And
But
1D to 2D. Why
so
can't I? Well, we have to scale it by the hat of the hattiness, right?
so I wrote this one out before, so I'll write it out again.
Yeah.
Let me.
Blah.
That's all right. So what we have is we have a position now. This is our quote unquote origin for drawing this axis into world space. So what we have is B, and then we want to move along this axis, like that way, or some amount of that axis. So what we do is plus axis times, well, in this case, Q. And that lets us move back and forth along this axis.
Yeah. Yeah, I mean, it's kind of obvious now, but just give me a sec. I need to wrestle with this. I mean, I know
that's
what
all
that
right.
is, and I know it. I mean, you're just scaling the axis to get by this distance,
Mm-hmm.
and then you're starting it by translating it with B first, like B, like yeah, duh. That's what. Yeah, okay. Yep.
So you can see it's actually relatively simple, but you actually have to, I guess, draw out the diagram and I guess think about it a little bit. So let's run that. I mean,
Well, we haven't done anything with it
we
yet.
actually need to draw it. Yes. Well,
Now that we have a prime,
this this aqua arrow that we've drawn. This is sort of the one we wanted. We wanted like a pink arrow, a light pink arrow that we had. So let's maybe drop those down to like 0.2 alpha, and then copy one and make it the new thing. I will attempt to catch up to where you're at.
I didn't really understand what you meant by that.
But draw an arrow. Draw a nice arrow from A to A prime.
Do that.
Now, unfortunately, the arrow is aqua. Oh, I meant the other way around with the alpha channel. Like draw this new one like nice and solid, and the other ones fade them way out. So we have the thing that we want. That's looking pretty good to me. So while I'm catching up code-wise, do you think you could move that red one down? Because that should be fairly simple.
I'll give it a crack. This is B. No, wait. Ugh. Hold on a second. can't be that. So. Really, but why not? I think I have to. I think Q is involved. Yeah, I gotta subtract Q. Q. Access times. Q. Come on. No, I need to do this. Why are you screwing this? Why are these red if they're red? Oh, it's just resharper something. Oh, so it's not the whole way, it's half the way. What if we just don't take Q away from that? Wee, Cartesian whack-a-mole. Not sure where to throw them. I'm not sure where the Q fits in. What I've got right now is obviously the correct amount and in the wrong place from the point of view of the x-axis.
Okay, let's. So far is not too bad. Okay, we're on the correct axis, so we've got b plus that, and then if I run that, we end up all the way out here. So this projection is obviously not valid on this axis. So we go back to the diagram. So axis. So this line is fine. We just got to figure out what that does. Okay. Let's have a look see. So what we have. We're trying to get this distance from there to there, and this distance from there to there. So you can see how, like Q, we have these other distances there and there. So does that make sense, what I've just drawn?
Mm-hmm.
Okay. So what we have at the moment is this distance here. So this is what min is originally, and this is what max is originally. So what we're trying to do basically, so those green ones are what we have at the moment. I'm going to draw it in a different color. Let's go with sort of a dirty, oh, that's basically invisible. Let's go for sort of a yellowy green. So we have those distances there. We want to get this distance here and this distance here.
Okay. Yeah, right.
And you can sort of see, basically, if we were to just chop our diagrams like slice, you can see that that's sort of how we get those distances. Just to draw the minimum case just on its own, we have this distance here. This is the current min, and we want this distance here. And hopefully it's pretty obvious what needs to be removed from that, because recall that B project is this distance on this axis. So that should be fairly straightforward.
Yeah, isn't that what I have here?
Circle A project minus radius minus B project. Min's correct. So and the max is exactly the same theory. So you can imagine if that's how we got min, max is this distance here, and we want this distance here. So we've just got to subtract B project.
Yeah.
And what do you know? We have that working. Now if we were to say, try that for all of the axes. It's a bit of a mess, but the red lines are correct. So you can see all of the ones that derive from the circle are obviously, lined up directly with the circle, and these horizontal and vertical ones, as messy as this diagram is, cover the projection of the circle onto this axis. So are you happy with how that's working?
Oh, sure. Yeah, I mean, it took an hour.
That's all right.
Yeah, I mean, most of these we don't even really.
So we don't need.
Really even need.
No, we don't need the other lines, and in fact, the light blue one's definitely wrong. Like, if we get rid of that, now this diagram suddenly looks a whole lot less messy, because you recall that the light blue one we were drawing was incorrect because it was origin relative. So now, yeah.
Sorry, which one was incorrect? The blue-violet one?
That one as well, because that one, goes from B to the axis B project, and this is A to axis times A project. Both of those are origin relative. So you can see that, like, this one is going up to you can imagine like a line coming out of the origin going there, and a line coming out of the origin connecting to that one, and the same with this, a line coming out of the origin connecting to that, which is, is not wrong mathematically, but it's obviously not what we want to draw, because it's not. It depends on their position relative to the origin. So if we scroll the window way over here,
I don't know why I don't have yours.
Those arrows would be wrong. I think you might have deleted the wrong one, or
this is the purple one. You don't want that.
Sorry, B is.
So this one goes, and then I'm just gonna look at yours, and then the 7 ones goes. This one stays.
Yes. So I've just called this circled up position, but in fact it is A to A prime. That should work.
Yeah, the name A isn't helpful anymore in terms of people who would read this code later. These variables don't make sense.
that was the next thing I was going to say. It's like, all right. The whole reason we had to go down this road of being like, okay, here's A and here's B, is kind of because we have two positions.
We do, yeah. The circle is explicit, and then the position of the position data for that axis also is a separate position.
So we should try and come up with things to call A and B. So I mean,
okay.
So and really this error comes from. Because naming things is important, from calling this positions. So we could call this. Do you have any thoughts on what we could call this?
Oh, what? Oh, the area, this array.
Yeah. So the axis origins, perhaps. Axis start.
Axis positions. I mean, I don't know. I don't know if that's particularly contentious. I mean, we're gonna move these things anyway.
Well, no. This is actually a legitimate thing. Like we're gonna have axes. When we do the calculation, we'll be doing it blind as such. Like we're not going to be drawing them, so we won't actually need this necessarily, because you can see where B is getting used. It's getting used to draw stuff, sort of. We'll have to fold this in a sec. as well. But we should come up with a sensible name for this so that we can go through and rename everything. So let's call it axis base. Let's call it that. How's that sound?
Sure.
So we can go through and call that B axis base, and then we can call A position now if we were so inclined.
I call them both axis base, but we can call one of them axis bases.
Yes, that's a very good point.
And then this one is, you wanted to call A axis position.
So A is the position of the circle. So where's our buddy A?
All right, circle position. Okay. Although we even really need a variable for it, we can just call circle position twice.
We certainly could. So why don't we do that? We'll get rid of A entirely.
We have the A and B projection. So A projection is actually the circle projection, right?
Well, now before we get too deeply into that, let's have a look, because we can actually get rid of A prime as well, because it only gets used once. So what we want to do is take this and just replace A prime, because you'll notice we have down here effectively the same thing. We have the axis base plus the axis times a distance.
Yep, and then Q just happens to be that distance. We can get rid of Q as well.
Well, let's see where Q gets used. Q gets used once, yeah, exactly. So
this is, yeah, and then now it actually kind of makes...
Now we can go even further. We could actually possibly undo that change. Keep Q for a second. Because what you'll notice is we actually have Q appears here. So we can do a little bit of algebra and rearrange this. So we've got A project minus B project is Q. So we could just say Q
minus circle radius.
And Q plus circle radius. So now we've vastly simplified. You can see that this math is starting to look a lot neater.
And now we want to keep Q because obviously it's used all over the place.
Exactly. So all we need to do now is think, okay, we have these three variables that have terrible names. Let's try and name them. So we have, I guess we'll call this the circle projection.
Yep. And B is the axis projection.
I'm gonna overrule you there and say it's the axis base projection.
Okey-doke.
Because we'll be talking about like projection onto an axis. You can sort of see like the axis projection might be just a regular old projection, whereas this is the projection specifically of the axis base.
Right. Yeah. The position to the axis. Right. The base is the position. Right. So then Q is the distance.
Now, I'm thinking now we have this situation. I'm thinking about this more, and what we really have. Let's split this one out. I know I got rid of A prime before, but let's say that this is float. This is axis times. Sorry, I'm just having to think about this. Yeah. What we have here, we have kind of two ways of expressing it. We have the circle projection. I'm just going to pop this in here temporarily. And we're offsetting it by the circle radius. This gives us a minimum on the axis. This axis base projection, if you recall, the axis base and everything derived from it is only really useful for drawing. hopefully it makes sense why that's the case. Does that make sense?
Um, the axis space is only useful for drawing because.
I just want to see if this code runs real quick, and I can probably show you something.
Well, I don't really know why it's only useful for drawing, because I mean, I kind of care about my shapes in the world, and I know they have a position, and I happen to know the axis space is the center of those shapes.
So here's a diagram. So you're happy with what this diagram, like what this code is drawing so far. Okay. Mm-hmm. What I'm going to do is I'm going to go in here and make a little change. And in theory, this is what would happen if we start ignoring the axis space. And what happens is it moves where our axes are situated all the way up to the origin. All of the rest of the mass is correct. So when we get into a position,
but we still don't. I mean, I still not sure why it's only drawing related, because now it's almost like, sure, you've made the axis space generic, but that just means like we're going to be testing against other objects, right? So I was assuming that now you're just like oriented relative to an object that happens to be at vector 2, 0.
So what's going to happen?
In order for you to do.
What's going to happen in the future? Oh yeah, sorry. Paste that in. What's going to happen in the future is we're going to say, let's go green. We're going to take this rectangle and we're going to take this axis here, just for the sake of example. That's not the right one. We're going to be projecting up onto this axis. So we'll have that there. We'll have, this one coming up there. We'll have this one here. And we'll have this one here. And we're going to end up with an arrow something like this.
Right, we haven't even gotten to that yet.
We haven't gotten to that, but you can hopefully tell that we're fairly close. Now, the point that I want to make is basically the result of the calculation we're going to be doing is the comparison between these two axes. So we're going to, in 1D space, we're going to be getting this arrow here.
Oh.
And so hopefully what you can see is that this arrow here.
Why do we get that arrow? Why aren't we just drawing? Why aren't we just projecting from the bottom of the green arrow up to the axis and the bottom of the red arrow up to the axis and seeing if they overlap?
Because we already are on an axis. So this green axis that I've circled, we're on this axis. So we've got the red arrow on an axis, and we've got the green arrow on an axis. And we're going to do the separating axis thing. So we're going to be like, let's compare the two ends of these things and see if they overlap and how much they overlap by, if they do overlap.
Okay.
But the point that I wanted to show you is that calculation is the same no matter where the base of the axis is. So you can see now I've turned that back to this form, and if I draw that, if I can identify that same axis, that's that one. Okay, so this is the axis that we were using, is this one and this one, and we've just moved it a bit, and hopefully you can tell, we project onto that, it ends up there, and then the purple is just this.
Yeah, it makes sense. I get it.
Terrible drawing aside, in theory, if we've done everything correctly, that's going to be the same. I know it doesn't look the same, but that's entirely because I'm not that good at drawing, apparently. Also, I'm not sure I picked exactly the same axis, but hopefully you can tell that value is the same.
Yeah, I get it. Yeah, we only need this because we're trying to visualize it, so we need to convert it.
So
these are just very theoretical mathematical 1D, like a number lines can be wherever they want. You can draw them anywhere you want to draw them. So the numbers are what we care about, like the actual math is what we care about.
So
yeah, I get that.
This is the form of our drawing. So it's still running. So hopefully this particular formula is familiar at this point.
Yep.
What I'd like to convert that formula to is a formula that we can use for drawing still, and we're going to expand that out to x minus some axis transform, which is going to be the same as axis-based projection. So that, or that. And so once we get to that, does that transformation there make sense?
No.
Oh, well, let me. Does that transformation there make sense?
Well, I mean, yeah, but now you've just renamed circle projection to x.
Yeah. So this is x, but the thing is, this is x. This same form is going to work for our min and our max as well. Because what we can do here is we can do a little bit of algebra and have it so it's like, okay, this is circle projection in one form, and then we have min and we have max. But the rest of the formula stays the same. So just x is how far along the axis we are.
I'm done.
Let me just basically finish up this train of thought because it makes sense in my head, and hopefully once we code it up it will make sense. So I'm going to call this axis-based projection. I'm going to call this the axis transform, and in fact I'm going to include this negative symbol here, so I'm going to turn that into a plus and stick the negative in there. So nothing too hairy so far. I've just gone ahead and done that. Now we have this format of a formula, and so what we want as a result is
wait, does q now have to be plus?
Yes, although I'm about to get rid of q. So
well, okay.
So I've added these brackets in here. So I've got rid of q, and I'm going to do the same thing down here. So we've got axis base plus blah de blah de blah, and go on to another line. So min and max. And so what we've done here is we've built in this minus axis-based projection. So now we're just in the form, I mean, we're just in that form, I guess. So this is just a little bit of algebra. And the reason for this bit of algebra is so that all of these are in this, we've got a consistent way of drawing or of getting a position on an axis that's transformed to a particular axis base. Hopefully that makes sense.
You don't have. Oh yeah, just
yes. So
sorry, you haven't. You're not. Yeah, you're no longer.
Because I built that into.
Remove all the components. Yeah.
I
get it. You're trying to separate what's drawing code and what's logic, so that you can reuse this in actual code as opposed to.
Yes, and there's another algebraic reason for doing this transform, which I'll show you. So hopefully, if we run this, it does the same thing. We've got our circle and our thing, and the transforms are all correct. We're still all drawing correctly. Haven't made any mistakes. Good. Mm-hmm. So what we can do now is we notice this, oh, this format here we've got axis space plus that, plus that, plus that. We'll do a bit of, we can do a quick bit of algebra here to make our lives even simpler. And that is if we move the axis inside the brackets, suddenly we have this, which is constant for the axis. So if I just shuffle that around, that whole section becomes constant. So what that tells us is the value we have for axis base is not very useful. So I might wrap it up here, but what we will want to do is be like, we can just turn this into like, you know, from the axis plus that times that. So that's that little algebra transform. So let's call it there. And we'll worry about that bit of algebra later because I think we're running well over time at this point.
Yeah.
Cool.
And my brain stopped working about half an hour ago.
Yeah, that's fine. All right. 3, 2, 1.